The front side of our opener is basically lesson 8.1. We're using the rectangular area model to expand, which I feel like you guys have pretty well, you have it down. So this first group of numbers here represents the what on my area model? The height. So my height that I put first is?
5.
And then what's my second height?
3.
Okay. Then the second group of numbers represent the length. So my length that goes first in my upper left-hand rectangle is? And then the length of my other rectangle is? Okay. Now the purpose is basically you guys would multiply these binomials together, but we're using the area model to do that for us. So what we're going to do is find the area of each individual rectangle and then find the total area of the model, okay? So how do I find the area of my first rectangle here? Okay, so I'm going to have A equals, if you guys want to skip the A equals at this point and you just want to put height times length, that's okay. So what's my height?
A.
Times?
2A.
Equals?
10A. 2.
Okay, so when I'm grading your guys' quiz, what I'm looking for is that you labeled your height, you labeled your length, then you took your height times your length equals your area. So I'm looking to see that you have this in order, okay? The area of the top right rectangle, find for me, Logan.
Top right.
Mm-hmm.
5A times 7. And I got 35.
Bottom left, Hannah.
3 times 2A.
E-
6A.
Maddie, the reason why the boxes aren't lighter, I already had all these made. Okay, I told you I'd make the boxes lighter, but they were already made for this week. So next week or when I have further ones, I'll try to shade them. Okay, bottom right, Jenna.
3 times 7. And that's 21.
Okay, from here, now I need to find the total area, which means I'm going to add each of the areas together. But I could only add certain areas together. Which areas can I add together, Ben?
Top right, bottom left.
Okay, so the like terms. And then I go up to the right and I write my final answer, which equals, what do I write first? Which term goes down?
10A.
10a squared. If you say 10a2, that's what it looks like, Ben. That's not 10a2, is it?
2. Wait. 10A carry top 2.
Okay, then what?
41A.
So positive 41a. And my last term?
Plus 21.
And then I'm going to box it. I made this front part of your quiz worth 14 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So since you don't write yours in your box, I'll just look to see that you have them in the right order here like this and that you have it labeled. Okay. Questions? All right. Let's look at the back side. So the back side, what we're doing is we're finding the greatest common factor for each of the following groups. We want to make sure that we show all our work and we box our answer. So in order to find the greatest common factor, the easiest way to do that is to go ahead and make our factor trees. So I'm first going to make a factor tree for 48. Now when I'm making these factor trees, what number am I looking for? What number am I working my way towards?
2. 0.
Okay, Ben, you said I'm working my way towards a 2. Why? It's not always necessarily a 2, but a 2 is an example of a what?
Number that can be reduced.
A number that only has 2 factors, which makes it a, what's that called? Prime number, yeah. So we're working our way to prime numbers. So what are 2 factors of 48?
2 and 24.
Do you have to use 2 and 24? Nah. Okay, 2 is prime because it only has 2 factors, so I circle it. What are factors again?
2 prime numbers or a prime
No, what are factors?
Oh.
2 is a factor and 24 is a factor. When I multiply them together, they equal 48, right? So factors are just numbers I use to multiply together. Okay?
3 and 16.
Say again.
3 and 16.
3 and 16? Is that what you use for 48? That's fine. You can use that.
But I did mine the other one.
Huh?
I did mine the other one.
What do you mean? How did you just write out and not do the tree? Because you only want prime numbers. 16 is not a prime number, so you have to break 16 down.
Oh, so you gotta do.
You have to get to prime numbers. Yep. Okay. But you could use 3 and 16 in a tree, then you're going to have to factor out 16. Okay. What two numbers can I multiply together to get 24?
2 and 12.
2 and 12. 2 is prime, so I circle it. What about for 12?
2 and 6.
Did somebody else use other numbers?
No.
If you did, it's fine. And what do you use for 6?
2 and 3.
Now here's the main part though. Once we factor it out and we get all our prime numbers, your prime number should match what I have up here. Okay? So let's go ahead and factor 60 then. So what can I multiply together to get 60? You can't answer this one. Thank you for your participation. Bueller? Bueller? You guys seen that movie? Anybody? What are two numbers I can multiply together to get 60?
30 and 2.
Okay. So 2 and 30. We know 2 is prime. What about for 30?
15 and 2.
Okay. Jenna just finished this one up for me.
3 and 5.
Okay. Do we all understand why I'm circling these numbers here? Because if I try to think, what two numbers can I multiply to get 3? I'm only going to have the number 1 and 3 itself, because 1 times 3 is 3. So it only has 2 factors. Any number I didn't circle, I went and broke down until I got to the prime factor, okay? So what do I do with these group of numbers? What do I do with these prime numbers I came up with?
Put them from least to greatest in order.
Yeah, so I'm going to put them in order from least to greatest.
Circle the factor pairs.
I hope you're a step ahead of me here. So 48 in order from least to greatest. Logan, what would that look like when I rewrite it?
28.
Mm-hmm.
Yeah. 2 times, no.
Yeah.
2 times 2 times 2 times 2 times 3.
Okay, and what about for 60?
2 times 2 times 3 times 5.
Okay. And then from here, Logan, what's my next step? Hey, Danny, do me a favor and flip. Let's see what this... Somebody help him?
Find the ones that match.
Yeah, what are the ones that match or that I have in common?
2, 2, 3.
2, 2, and a group of 3s. So then I'm going to drop down. My greatest common factor is going to be 2 times what?
2.
Times, which equals? When you multiply those 3 numbers together, what do you get? 2 times 2 is? 4. 4 times 3 is? So 12. Good.
Can I do the next one?
Nope.
So have you seen Cabin in the Woods?
No. But we started watching, what's that? The Silent, the Quiet,
Oh, the Quiet Place?
the Quiet Place. My husband and I did on break. Because usually our other 3 kids, they'll just kind of zone out when we watch movies.
You know they're going to make a part 2 of the Quiet
Yes.
Place this year?
Yes, I saw that.
I feel like
But then the kids started watching it, and they were getting freaked out. And my 3-year-old saw where the other little guy got taken away. And so then we thought he'd zone back out to his iPad. And then he's like, is that person going to die too? And I'm like, ooh, we should probably turn this off. So we didn't get to finish it. But then I got all nervous, like, did the lady have her baby? Did they all make it? If you haven't seen it, sorry, this is totally going to ruin the movie for you. But then I saw that part 2 is coming out. So then part 2, you see all the main characters still there. I don't know if all of them, but majority of them. But don't tell me because I do plan on watching them.
To your knowledge, I feel like they're coming out with sequels with all of them.
Well, this
Like
year could
for-
be like the horror movies. And so they're already making The Boy. And
like
what
John-
is
That was a good
Do I like what?
movie, The
John
Boy.
Krasinski.
Yeah, but this
What's
time
that?
Dolls
The
Possessed
dad
or something
movie?
like that.
Well, the doll.
Yes.
Oh yeah, because I forgot.
I just saw the trailer of that this morning.
Okay, here we go. We got to get back on this. Okay. Okay, so how do I find the greatest common factor of numbers with variables? what am I going to do? I'm going to follow the same steps, right? And I'm going to follow the same steps, and I'm going to ignore the variables to the very end. So I'm going to go ahead and factor tree 30, 75, and 45. So what are my factors for 30, Riley? What two numbers can I multiply together to get 30? Again, if multiplication is not your strong suit, that's okay. I highly recommend that you get a multiplication chart back here because it has all these different numbers you can multiply together to get other numbers. 3 and 10, that works. If you use 5 and 6, that works too. If you use 2 and 15, that's fine too. Riley, can I factor 3 or is it a prime number?
No.
So it's a prime number, I'm going to circle it. What about 10?
Yeah.
Okay, what can I multiply together to get 10?
2 times 5.
Perfect. What do I do with my 2?
Circle.
And what do I do with my 5?
Circle.
Maddie, factor 75 for me, please. I think of it like money. 75 cents.
25, 3.
Perfect. What do I do with my 3?
Circle it.
And my 25.
5. Yeah.
What do I do with my 5s?
Circle it.
Oh, good. Danny, 45.
So not 5.
5 to 9,
Okay.
circle 5, 3, 3, circle 3, 3.
Okay. Now, according to my notes, because I'm looking at my 8.2 notes because I can use them on my quiz tomorrow, I just finished step 1. Step 2 says find the numbers or find the prime numbers that they have in common. So I'm going to do that by writing them out in a list. So I have 30, and I'm going to write my list, least to greatest, to keep my work organized. So I have 2 times 3 times 5. And then I had 75, which was 3 times 5 times 5. And then I had 45, which is 3 times 3 times 5. Now, my step 2 says, I only circle what all 3 of them have in common. So do they all have a 2 in common?
No.
No. Do they all have a 3 in common? Yes. Oh. So they all have a 3 in common. What else do they all have in common? A 5. So I'm going to circle those 3, that group of 3, and that group of 5. Okay? Down below, I'm going to write GCF. So what 2 numbers am I multiplying together? 3 times 5, which equals?
15.
Okay, 15. Now it's time to pay attention to my variables. So what my notes say to do, instead of writing all these variables out, because that would take forever, my notes say, when using variables with exponents, use the smallest exponent for the greatest common factor. So they all have to have the same variable, because they all have to have it in common. And if they all have the same variable in common, then you use the one with the smallest exponent. So do all of these have an x in common?
Yes.
Yeah.
What's the one with the smallest exponent? x2, so x squared. Do they all have a y? So which one's the one with the smallest exponent? Y to the what power?
Third.
3, 2, or 4? Which one's the smallest number?
2.
So you use 2. Do they all have a z?
No.
No, so they don't have that in common. So it can't be part of our greatest common factor. So therefore, 15x squared y squared is our final answer.